Good afternoon, all of you. Am I audible to you?
Yes. Yes, Tirili. Yes.
Thank you. Okay. So welcome to the International Conference on Logistics and Supply Chain Engineering 2021, virtual conference organized by the Central Chapter of Chartered Institute of Logistics and Transport, Sri Lanka. As you already know, CILT is one of the prime international professional and academic organization, which has over 100 years devoted excellence in transport and logistics globally. So I'm Tilni Ranasinghe from University of Peradeniya, as well as a member of CILT Central Chapter. I'm the session coordinator for today's technical session number 2, in which we will have 5 paper presentations, abstract presentations, which has IDs 24, 25, 41, 32, and 49. As you already know, the presentations are pre-recorded. After each video, we will have a question and answer session, which is 5 minutes. And presenters and authors, please rename your Zoom using your abstract number and the name. So this technical session is chaired by Dr. Chaturani De Silva from University of Sri Jayawardhanapura, with 2 co-chairs, Dr. A. Tibbatuao from University of Moratuwa and Dr. A. Kaviratna from University of Calgary. Thank you so much for joining on time. Without any further ado, I would like to invite the chair to start the session. Dr. Chaturani Silva, over to you.
Thank you very much, Tilni. Can you hear me?
Yes, we can.
Thank you very much for inviting me as the chair of this technical session of the International Conference on Logistics and Supply Chain Engineering 2021. This session, I think we have 5 papers to present. So actually these are going to be very interesting research, basically on distribution and transportation area. 2 papers are on that field, and also technologies used in logistic and supply chain management. One is also on construction supply chain management. So without wasting much time, I would like to introduce the presenters. First presenter, the audience. I think it is paper number 24. Am I correct, Pirini?
Yes, paper number 24.
24. The topic of this research is planning of a distribution network utilizing heterogeneous fixed fleet with balanced workload. This paper has been co-authored by Punsara Hittiarachchi, Subodha Dharmapriya, Asela Kulutunga from the Faculty of Engineering at the University of Peradeniya. Please welcome the presenter.
Hi, I'm Punsara Hittiarachchi. I'm from Department of Manufacturing and Industrial Engineering, Faculty of Engineering, University of Peradeniya. The name of our research is planning of a distribution network utilizing heterogeneous fixed fleet with balanced workload. Distribution-related problems are formulated in literature on basis of vehicle routing problem. The typical vehicle router problem aims to find optimal route plans to serve the set of customers. They have some common constraints. Normally in literature, many literatures, they consider the homogeneous fleet of vehicles. And each vehicle route starts and the ends at the same depot. Each customer is registered only once by one vehicle. In this research, we use heterogeneous fixed fleet fleet, and also we consider the workload balancing. The distribution operation of ABC brewery manufacturer considered in this study. The distribution center is located in Beruwala. They have 147 outlets and the distinctly clear demand is 1 to 600 units. The heterogeneous fleet, the port trucks, and they have capacity with 650, 810, 50, 900, and 1050. They work 8 a.m. to 6 p.m. for 7 days, and the company expects us to reduce the overall distribution cost and improve the vehicle utilization above 80% and optimize the fleet with equal workload. Our aim is to optimize the distribution operation in terms of distance and equal workload. The objective is develop the mathematical model. They solve the mathematical model using appropriate algorithms, and they identify different scenarios and identify the effectiveness of the alternative strategies, and they make recommendation to enhance the distribution network performance. First, we formulate the problem mathematical, then we develop the mathematical model, then we solve the mathematical model using alternative algorithms, then this we test the different scenarios based on the baseline model, then we provide recommendations. So this is the problem formulations, and this is the mathematical model. The objective function is to minimize the total distance. We use constraint all vehicles start and ends with the warehouse. The total sum of the outlets demand must not exceed the capacity of the assigned vehicle. Capacity utilization of the route must be greater than 80% of assigned vehicle capacity, and all the vehicle must complete within working hours. Total distance of the four vehicle must be within the predefined R percentage range of average truck traveling distance. In this case, it's 30%, and this is used for the workload balance. So we use simulated tunneling and genetic algorithm to solve the mathematical model, and this is how we implement the meta-heuristic method. So first we define the algorithm termination criteria. Then we consider whether the termination criteria is satisfied. We generate the initial solutions, then apply local such strategies. We check the solution is improved. Then the check whether the constraints are satisfied. So we have a lot of constraints. Then we go all the way round. So this circled steps may be changed or altered according to the meta-heuristic approach, which is simulated tunneling and genetic algorithm. So this is the results of the baseline model. As you can see that GA shows better results than SA. But this table one is the one time based on one-time results. The figure 4 in the shows that the distribution of the results for 50 runs for both SA and GA. So since in some cases we observed that SA is a better approach for solving the problem. Sometimes we got the GA better result. Since the solution space is very much higher, the observation of one-time results may or may not be significantly valid for the population. So we use the pairwise t-test using 50 times of both algorithms. So since as the shown here, since the p-value is 0 less than 0.05, we conclude that GA shows the better results for 95% of confidence level. Then we define scenarios based on the baseline model. Scenario 0 is the baseline model which we use to complete it. Scenario 1, we exclude the 650cc truck, which is the smaller capacitated vehicle. Scenario 2, we exclude the 850 and they use other 3. Scenario 3, we exclude the 900 capacitated vehicle. Scenario 4, we exclude the largest capacitated vehicle and we use other 3 to distribute. This is the table 2 shows the results we obtain from the results. As you can see that there is a variation, and this is also based on the one-time results, so we can't be sure that it might not be significantly valid for the population. So we conduct one-way test. The test Test have two phases. One phase is checking whether these scenarios are significantly different. As the calculation shows here, since the p-value is less than 0.05, we conclude that the scenarios are significantly different. Then, according to these plots and this plot, we concluded that scenario 1 has the lowest means among all the population. So, as the model summary suggests that the model explains the behavior of the population by 57%, 57.29%. In conclusion, we concluded that genetic algorithm is comparatively a better option to solve the problem. The total distance of the current system is 1,852 kilometers, and average utilization is 2. In scenario 2, we reduce the distance by 10.25%, and we increase average utilization to 96%. So then scenario 1, we reduce it by 12.95%, and the average utilization we improve to 96%. Finally, we conclude that scenario 1 is a better option compared to the other scenarios. The mechanism is removing the lowest capacitated vehicle, reduce the frequency of going back to warehouse for refill. The opposite mechanism is the conclusion can be observed in scenario 4. As you can see that in scenario 4, it shows the higher range of distance. Since the highest capacity of vehicle is excluded from the fleet, the frequency of going back is increased for other vehicle that also increase the distance, total distance. So that's it. Thank you very much.
Thank you very much, Ponsara, for your nice presentation. First of all, I would like to open up the session for the audience to ask questions from the presenter, if you have questions. Questions?
Yes, thank you very much for the presentation, and hope I'm audible enough. So I have one question. Did you consider the number of vehicles in each category, each capacities?
Yeah, they have only one vehicle for one capacity level. So they have only 4 vehicles.
Only 4 vehicles?
Yeah.
So, like if you are removing 1 vehicle at a time, is like they are using the remaining 3 vehicles for the entire distribution. So, did you consider the time, the response time, I mean the total, the time associated with the entire distribution network when satisfying the demand as well?
Yeah, one of the constraint was they have to satisfy between the they have to go complete a 1 trip between working hours. That means we have 10 hours including loading time.
Which means for 1 trip or for the like entire, or means satisfying the entire demand, the demand locations?
Yeah, to define to distribute the entire demand for 1 vehicles, we are use that they had to be in less than 50 week 70 hours, less than 70 hours, and for 1 trip they have to complete within a day. So we have considered that 1 trip should be less than 10 hours. Cumulative of all the trips should be less than also 70 hours.
Okay. Thank you very much for your answers.
Yeah, thank you.
Thank you. I would like to invite the co-chairs, Dr. Tibbotuava and Dr. Kaviratna, for asking questions. I can see some questions on the chat from the audience. I would like to ask these questions from you, Ponsara. What are the software you used? What software tools you have used in your analysis?
Yeah, to build the algorithm, I use Python. I had to build from the scratch since the inbuilt modules of the Python's libraries are not compatible with practical scenarios. Theoretically, simulated tunneling modules and libraries are okay, but when it can come to the practical scenarios, I had to build entirely new from the scratch, and to do the statistical analysis, I use Minitab software and the Excel as well.
Okay. I would like to ask one question from you. You tested the models using SA and GA. Can you please explain the variables? What is SA and what is GA? It was not very clear to me actually.
Yeah. SA means simulated tunneling. That's one of the meta-heuristic methods inspired in nature, and the also genetic algorithm.
Okay.
GA means genetic algorithm that also inspired with the evolution theory. So the Peter's one will be survive with the next thing. Should I explain how I implemented it? Or?
If you can briefly explain that.
Yeah. In XA, I have initially generated solutions, then search all the all the some neighbors, and they selected the best. So then again I selected the initial solution, and then they check the another the neighbors, and so goes on until their desired temperature level. That means the desired terminator criteria reach. So in GA, I have generated initial gene pool, then initial solutions. Then after that, I selected the fittest one with the constraint satisfied. Then I generate the another genetic pool using those initial solutions. Selected fittest solution. Then again, I'm doing for generations. About I think I did that for 100 generations with the genetic pool with 2000 solutions to achieve the greatest best solution.
Thank you very much for your good explanation. So we can move to the next presentation now. Thank you very much, Sara, for your presentation.
Thank you.
I would like to invite the next presenter. That is paper ID number 32. This research is CPSTL Filling Station Self-care mobile application extending the connectivity of Sri Lankan downstream petroleum industry. This paper has been authored by Varuna Gunasekara, Ceylon Petroleum Storage Terminals Limited, Sri Lanka. Over to you, Varuna.
Hi, madam. Thank you for the opportunity. I think the video will be played right now, is it?
Yeah.
Hello, everyone. I'm Varuna Gunasekara. I represent the Ceylon Petroleum Storage Terminals Limited. I'm here today to present my paper on CPSTL Filling Station Self-care mobile application, which is extending the connectivity of Sri Lankan downstream petroleum industry. Thank you very much for all the organizers of ICLSE2021 and the Chartered Institute of Logistics and Transport. So basically, my paper is regarding the sales order process of the downstream Sri Lankan petroleum industry. So the research background is basically sales orders, how the customer and the supplier is dealing with their particular sales orders. So it deals with business-to-business information systems, and especially the fact that the supplier's information system is being integrated at the customer's level. So with respect to the Sri Lankan downstream petroleum industry, it has got two major marketing companies and one logistics company, which is CPSTL. So in here, what we're dealing is about basically regarding the sales order process, how it is being used. So one of the biggest problems with respect to the sales order process, which was existing at the time, was that the supplier did not have any information regarding the storage levels of the customer. In this case, that is the petroleum industry and the filling stations. So during the study, we have found out that most of the sales returns or the consignment returns take place due to this factor, which is 37% to be exact. And another 13% of this is due to the inefficiencies of the existing sales order process. So in that context, with respect to the methods that are being handled, we have observed that several multiple manual and computer-based systems are in order. That is, that customers are placing the sales order via faxes, emails, sometimes by visiting the plant and filling out a document, or sometimes via a phone call. So the personnel at CPSTL is capturing the details of these sales order via these traditional methods, and then utilizing or reproducing the sales order at SAP ERP system. And so these are basically primary modes of communication, and they have been maintaining hard copies, keeping records of documents. So this gap has been a bottleneck, or maybe it has led to several losses due to return notes. So our research has been focused on to look at the previous studies and see how sales order processes and how the customer and supplier integrations take place, and what they have found out, and what studies have been carried out with respect to this. Then to identify the pain points, the bottlenecks, and the inefficiencies of the existing system. Then to come up with the methodology to eradicate all those drawbacks and come up with a proper systemized solution which will facilitate or ease all the pain points in the previous process, and to come up with something new which is a value addition or a benefit which was not there in the previous system, and then to devise a particular solution and implement this and streamline the process. So what we have with the literature review and the thing is, what we have come up as a methodology to implement is that the best possible solution needs to be a mobile application that is considering the web application and the length of the customers. Like we are having almost CPC customer or a filling station is there at any particular point in the Sri Lankan geography. So it can be anywhere. So the mobile application is the best thing. Like it can reach almost any location, not 100%, but what we have come up with, the best solution is to come up with a B2B application, definitely. And that we have chosen not to be a web application, but to be a mobile application. So what we are planning to do is like to get the original sales order in the electronic format to a mobile application. Then it will be transferred to an intermediate server. Then it will reach CPSTL site. Then at the end, it will be directly integrated to the SAP ERP system. So from the starting point or the origin from the CPC filling station, the sales order information will be captured electronically. So which will minimize the repetition of one person saying something or writing something down and faxing to the another. So from the point of origin, the sales order information will be in a digital format. So the digital, the next phase will be the integration to the SAP ERP system. So for that, we'll be having the predefined SAP business process management methodology. So it will be a kind of a project. Then there will be as-is analysis. There will be a 2B process design. Then the solution transformation on how to capture the data and integrate with the SAP transactions and processes. So as my paper goes on to say, the system implementation has been completed. We have come up with the mobile application with all the dealers, CPC dealers or CPC filling stations in the country. They have done this in a strategic way. Like we have not gone for island-wide implementation immediately. We have gone with the regional offices, the say 10 filling stations at a time. We have given them the mobile application. We have trained them. Then we have asked them to enter the stock levels at their filling stations. Then for a period of nearly 2 years, they have been using the mobile application. And we have been encouraging them to use the mobile application, which is somewhat hard in change management process. So over the 2 to 3 years, it has been, I mean, all the filling stations have adopted that. And currently, all the dealers, I say to 100%, more than 1,150 dealers have been using them. So they've been their traditional methods like emails and faxes and telephone calls have been replaced by the mobile application. And the next thing which we have achieved is like we have gained access to the information that how much of petrol 92 or 95 or super diesel or diesel, how much of the stocks are you having now? So with that information, it gives a leverage to CPSTL to see whether to prioritize which are the most priority or which are the filling stations that needs fuel faster, and say whether this load can be unloaded at the customer's location or will there not be any enough sufficient space and all that. And apart from that, all this time CPSTL, they were having only the stocks at their own storage tanks at their own locations. But with this implementation, they have gained access to the amount of fuel that is there at the island-wide filling stations as well, which is a big deal considering the fuel shortages and the other concerns which have been troubling the general public for so long. So now they have access to the information about how much stocks that are there even at the filling stations. So about the strengths of the application, this is almost a near real-time solution. Say that will be like almost 1 minute delay between the mobile application and the web server and the SAP. So the total maximum delay should be something around 2 to 3 minutes. So it's almost a near real-time solution. So it's not a perfect solution, but still with respect to the existing solution which we have been using for the past decades. So it's a online and real-time solution which we have almost eradicated all the human errors that have been caused in the past by both the customers and the CPSTL personnel. And the reporting mechanism has been flexible, and the users have been downloading both the sales personnel, the area officers, and even the dealers, the filling station staff. They have started maintaining their stocks and orders to a certain level. And the most important thing, we have got rid of the bulk prints and hard copies that we used to keep, especially the faxes. So it's like we have reduced almost up to 85%. 85% in the sense, still we are not, the CPC consumers are not using the mobile application, still the filling stations are doing so. So the rest of the things are still going with the old methods, and we have to transform the process in the same manner as well. So we have got digital backup of records. Say previously, if the hard copy is missing, you will not have access to the order placed by the dealer, but still in this new system, we'll be having digital backups of the information of the times, places, and all the mobile numbers which have placed the orders, and that there will be a backup and sort of a digital library. So access to customers' location information. Say the biggest thing we have done is like we have extended our information system to all the corners of the island, so that we have gained access to the storage information of the filling stations in the country. So with respect to weaknesses, there are quite a few. Say the solution is solely based on cellular signal reception. Although the telcos claim they have island-wide access, there are still blind spots, and there are very much weaker signal receptive areas. So even us, we are failing the same connectivity with respect to the filling stations. Like some of them are having difficulties in placing orders. So hopefully things will improve in the upcoming years. And the current mobile application is not that much of interactive. The features are at minimum level, and it's available on Android applications only. So it needs to go from Android to Apple phones and maybe tablets. And there are quite a bit of security features that needs to be added to the mobile application, encryption and all that. Say if we are supposed to implement features like online payments and mobile app payments for the filling station, so upgrading security features is a must. And currently it's being only used by CPC filling stations, so we need to extend them to CPC consumers as well. So as I've spoke, there are quite a lot of future applications that are having the potential. Say like we can impart the delivery notifications to the dealers, like whether your tank lorry has left CPSTL terminals and it's on their way. Maybe we can give a live track of the tank lorry, where the tank lorry is right now. Maybe the payment information. Maybe we can embed the payment gateway, as I told earlier, so that we can make the payment to the mobile application as well. Then we can have some sort of customer CRM features, customer relationship management features, such as way to provide suggestions, maybe rate the delivery drivers and all that, and to get up the complaints. Then we are currently working on notifications like broadcast messages, like to let to know the they be fuel price revisions, maybe the availability of CPSTL plants, whether they've been working on 4 days and all that, and what are the holidays. So as I've told earlier, say we can impart GPS or IoT regarding the fuel stock levels and where the particular tank lorry is, and the estimated time, maybe ETA for your location. So that has been the mobile application, like CPSTL Filling Station Self-care application, which we have developed as a solution after analyzing the pain points of the existing CPSTL sales order process, which we used to have. So we have been able to extend the boundaries of our information system towards the endpoint of the customer. So that's it from my end. Thank you very much. Thank you very much, ICLSE, for providing me this opportunity.
Thank you very much, Varuna, for your very explanatory presentation. I think it's a very useful application. I find that as these kind of developments are the things that happen in our country, in the logistics sector especially. I think there are loads of things we can do in this area. So first of all, I would like to invite the audience to ask questions from Varuna.
Yes, thank you very much, Varuna, for your presentations, and hope I'm audible. So you were mentioning about something related to value-adding features. What do you mean by value-adding features? Can you give some examples for value-adding features that you added to the applications?
Yeah, the basic objective of the application was to obtain the sales order from the customer, that is CPC filling stations. So while we have achieved the main objective, again, what we have added is like we have embedded a feature for the filling stations to enter the stock levels they are having. Say, for example, the filling station at Rajagiri is having this much of a, say, 10,000 liters of auto diesel. And today at 8 o'clock, they have uploaded as, say, for an example, 8,500. So with that, we have gained access to all the filling stations storage levels, so that we can have an idea about how much of a auto diesel stock is there at island-wide filling stations. So we have made it mandatory for them to put the storage levels on a daily basis. Otherwise, we will not allow the mobile application. I mean, we will not allow the customer to place their orders. So that has come as a value addition in the sense that the objective was to streamline the ordering process. Like what we were planning was to reduce the errors that have occurred in the manual process of placing orders. So while we have achieved that, again, we have gained the access to their stock levels. So that is something bonus. So apart from that, currently they are having a digital, I mean, the application stores the history of their orders, whatever the orders they have placed. So with their status, whether the order has been received or not. So those are the two most value-added features that we have given to them currently. But as I mentioned, in the future applications, we will be planning to add a payment gateway to that, hopefully, so that they can keep a track of their payments as well. Say for the filling stations or the products they are ordering, they can have the cash transfers in from their mobile application as well. Then maybe we can have a live tracking of the Bowser or the tank lorry which is carrying fuel from say Kolonnawa to Rajagiriya, or maybe anywhere to any part of the country. Say like it's the same thing that you see on maybe in Pick Me or Uber. We can indicate the same thing so that they can arrange their staff for unloading fuel at their places. So the most important thing we have done is we have gained access to how much of fuel we have available in the country's filling stations. All this time in the media also, what we are saying is like at Kolonna we are having this much, at Muthurajavala we are having this much. So apart from that, at the dealers locations or the filling stations also, we have gained access. Like even if this much is available at our places, even the resellers are having this much of a thing. So it's more than what we used to have.
Yeah, similar to the same content, like because you mentioned like you can access real-time stock levels at each filling station. So isn't it possible like to implement like vendor managing it, that kind of approach that you gain some control of the inventory level, like even before they placing order? Is it possible like for you to plan the inventory beforehand so that you can make ready your inventory beforehand by accessing those kind of information? Is it possible?
Yeah, that is not
like,
it's not,
or you have to wait until they place the order to process that.
No, it is doing at the real time. Say stock levels are not real time, but the order placement is real time. Stock levels, they are doing two stock upload. There is opening stock and the closing stock only. We are yet to have real time stocks at the filling station.
Okay.
But what is happening is like before discharging our oil, I mean discharging the outbound delivery, they are checking from the SAP ERP system, they are checking the current stock level at the filling station. Say suppose the tank is 10,000 and today morning we are having 8,000 and they have ordered another 6,000. So clearly there's only space for only 2,000 liters. So it will pop up an error in delivering that particular outbound delivery. So it will say like there is not enough storage at the customer's location to unload this delivery. So the delivery will be held, and the operator is supposed to call up the filling station and double check whether this has been happening, whether you can unload the thing if we send it now.
Okay, I
so
understand. Yeah.
That is 37% of returns happen due to this reason. Some big amount of I would say around 12% returns happen to this reason, saying that they have not enough storage location to unload the fuel. So it will be the best utilization of resources.
Okay, thank you very much. Yeah, thank you very much.
Thank you, Varuna. Since we have limited time, we would like to move to the next presentation now. The next paper is leveraging last plan system to improve construction industry logistics in Sri Lanka. This paper has been co-authored by Lakshan Priyadarshana from Access Engineering PLC Sri Lanka and Namal Bandarnayaka and Asela Kulutanga from the University of Peradeniya. Ms. Lakshan, you can start the presentation now.
Good day, ladies and gentlemen. My topic is leveraging last plan system to improve construction industry logistics in Sri Lanka. I am Lakshan Priyadarshana, and this is co-authored by Ms. Namal Bandarnayaka and Dr. Asela Kulutanga. In definition, logistics by the Chartered Institute of the Logistics and Transport, it's a process of designing, managing, and improving such supply chains, which might include purchasing, manufacturing, storage, and of course, transport. So, logistics, like many other aspects of the construction project, that has to be precisely planned in order to have an effective construction logistics. And also, studies prove that the communication is one of the main key having an effective construction logistics. So there are many factors influenced by the construction logistics, and we could identify certain important factors such as waste production, project cost, project time reliability, and also the improvement of the health and safety aspects. So to focus on the construction logistics, we're going for an approach using the lean techniques. So originally, lean is invented from the manufacturing industries, precisely speaking from the Toyota production system. And the key principles of the lean is to increase value and the quality while minimizing or the eliminating waste and the reduction of the production time and cost. So coming from lean manufacturing to lean construction, it's also the same. It's a production management based project delivery system, which is emphasizing the reliable and the speedy delivery of the value. So there are many lean construction practices available, but however, since the planning has a crucial factor for the construction logistics, and there's one lean construction practice which is more focusing on the collaborative planning at the production level, which is last planner system. So with that, we'll move on to the last planner system. So basically, in construction management, there's a tendency for the project managers to assign work beyond the ability of the work crew, so which is going for an average plan failure rate about 50%. So the term last planner means the person or the work at the operational level. Since last planner, that the person is in the best position to match the resources to accomplish the assignment with response to the downstream demand, the last planner system use certain lean methods to provide improved project flow, the precise workflow, and the improved project control. So we could identify the basic components of the last plan system, which is milestone planning, that the major milestones and the major phases, and we do the pull planning, which is also known as the backward planning, and that's the look ahead planning, which is about 6 to 8 weeks duration. From there, we identify all the constraints and we remove the constraints, and then we precisely make the weekly work plan. So out of that weekly work plan, measure what is the actual work done. So and that is also indicated from the plan percentage complete, which is also known as the PPC indicator. Then we analyze what are the reasons for the non-completed work. So this is like a continuous circle, and it's a continuous learning process. So the constraint identification is there. So the last planner is getting involved in the planning section to the short-term planning. So even the last planner system is increasingly adopted by the global construction industry when it comes to Sri Lanka, not just last plan system, but any other lean practices and the application of the lean principles are not that much widely spread, which gives us the significance of this research. So we are conducting this research to explore how last planner system could improve construction logistics in Sri Lanka, with the objective to examine the degree of adoption of lean practices in construction industry and to assess the readiness of implementation of last plan system in the local construction industry to improve construction logistics, and also to provide recommendations for adoption purpose. And there are certain limitations as well. This is limited to the construction industry in Sri Lanka, since this has a systematic approach. Only the construction companies up or above Z1 under the CR gradings has been concerned. So a systematic literature review has been done to identify the research gap. So in the pilot study, it was revealed that the comprehension of the lean aspects from the professionals stay at a very low level. So with the unavailability of the past project references in Sri Lankan context, since there's no availability of the there, it cannot build a conceptual model, so that a major qualitative approach was taken to conduct this research. Even the last panel system is a relatively new concept, a new system. It has certain characteristics from the traditional project management aspects as well. To assess those factors, a minor quantitative approach has been adopted to check the degree of agreement. So the analysis going on with the, from the both methods, followed with the results discussion and the conclusions as well. So the results shows that this is the 7 types of waste, which is very significant in lean, either lean construction or lean manufacturing. So the idle time, production, and the overproducing has been identified as the most significant waste type by the respondents. In this case, actually, when it comes to construction, overproducing is not a significant waste type, since the construction is a unique production, and also it is based on the downstream work demand. However, our results shows differently, and also the motion transport has moderately significant, whereas the processing waste, inventory waste has got the least significant identified by the respondents. Logistics. So the key components of the last planner system has been assessed separately. So coming to the phase planning and the pool planning, mostly the critical path method is the highly used under the current practice. Only the pool planning technique is applied for a certain cases where there are special technical involvement, such as M&E involvement. So we could see that there are a lot of impact with that phase planning or the pool planning, because there are delays in the foreign shipments, especially in the M&E section, and also sometimes it happens in the other way around, that the unnecessary stocks are at hand, so that they have to pay damages or the warehouse charges, and also in certain cases the assets are underutilized. And also we could see the local procurement issues due to the improper planning or the with the current planning system. And coming to the next one key element, that the involvement of the last planners, it was identified that the involvement of the last planners staying at a very low level, so very limited, and sometimes there's no involvement at all. Only in the applications where separate technical experts get involved, yes, the last planners are in the planning section, because they are the people who know how to do the work rather than the management. And also in certain cases, involvement of the last planners is based on their experience level as well. So this situation leads to more waiting time at the site and certain insufficient material at stocks, delay in local materials and the procurement, and also due to the urgency of the material, even the supply issues are there, such as based on their production time and project material delivery. So we could identify those problems. Also, the involvement of the last planner was checked separately, whether the involvement is low or high. So the similar results were obtained in here. And coming to the constraint analysis, another key feature in last plan system. So this is one of the this is under the current practice, which is identified significantly, and also the constraints are avoided by the experience and the root cause analysis. And also we could see the impact that the certain vendor policies are coming as the constraints. The low flexibility and the low flexibility in the internal management procedures, such as ERP systems and the other management processes which are established by the organizations. However, even though they are established for the betterment of the organization, sometimes to improve logistics, that come as a constraint. So coming to the analysis of the reasons for non-completed tasks, which is one of the key features, and is significantly important and highly practiced under the current system. Also, we could identify as a positive trend which helped to identify constraint in advance. And only in the cases where there are limited vendors or the suppliers, only in such cases we couldn't avoid, we couldn't overcome those reasons for the non-completed works. Also, the last plan system is more focused on the short-term planning, and we could see that the majority is using the monthly work plan, which is coming from the traditional project management system. So this should focus more on short-term planning. So coming to the conclusion, respondent identified lean waste types related to the construction logistics to a certain extent, as explained earlier. So, and the last plan system key features and the impact to the construction logistics. So the involvement of the last planners staying at a very low level, which leads to improper logistic management, as we identified that the insufficient of materials and the procurement issues. And also the finding reasons for the non-completed tasks are practiced under the current project management system, which is also coming from the last plan system, which is a positive trend to improve construction logistics. So to enhance these practices, first of all, the attitude of the management and the organizational acceptance of the system is very much required by facilitating training, awareness, and also the providing motivation for the last planners, giving some benefits for getting their involvement. They are the people who know how to do the work, and they have more idea of the logistics aspects as well. And also these things should start at the higher education systems, because it is vital. So the building awareness for lean construction and the last plan system and the professional logistics operations in the construction industry. So these things could be educated in our system as well. And also the further explorations can be done using more quantitative aspects and the approaches and the using case studies. So with that, I would like to conclude my presentation. Thank you and good day.
Thank you very much, Lakshan, for your wonderful presentation. It's a very useful study, I suppose. Do you have any idea about the current level of usage of last plan systems in our country?
Yeah, I hope you, I'm loud and clear, right?
Yeah.
Can you all hear me?
Yes, we can.
Yeah, okay. Well, actually, the study is more focused on assessing the last planner system for various aspects. So the last planner system is very new to our country.
Yeah.
So it is practicing very low level. So that is why even if you go to the industry and check, are you practicing last planner system, or not just that, forget about that, just ask what are the lean concepts you practice at your organization. They don't know, because the comprehension level is staying at a very low level. That is why I have adopted a different strategy to identify what are the key essence of last planner system, then ask those in very general terms. Are you practicing these things at your work, rather than saying the last planner system? So what I could observe was that these systems are implemented at a very low level, even the key components, but some of the components, without knowing whether it is a last planner system lean or not, they're practicing it somehow, because the project management is happening at the moment. So some of the practices are happening, but some of the practices are not, which are very vital. So the last planner system is a proven method. So we don't have to, enhance or do anything like that, but we could adopt that system and check the what are the improvements we could do. So how to get into their originated systems. So so to wrap up your the answer, yes, it is practicing at a very low level. We could say that is the answer.
Thank you very much. I would like to invite the audience and the co-chairs to ask the questions from Lakshan.
Okay, thank you, Lakshan, for your presentations. And because you mentioned you did a qualitative data analysis, is it like asking respondents the importance of different factors that you consider, or the different component that you mentioned in this presentation, as 7 type of waste related to the leans, and you asking about the measures to avoid these kind of waste in your organization? Is it similar approach you were using in your research?
Yeah, actually, I have adopted interviews and the focus group discussions as my major major data collection method. So what I did was, first of all, I paraphrased everything, without mentioning lean or any technical terms. Okay. I just turned them into very generalized terms, and I didn't directly approach us to the lean waste or the last planner system. First of all, I just assessed what are the problems that you face in the construction industry. So that is a very broad question. From there, I took them to the next step. So what are the waste types that you have identified? So not just like waste types. So there were certain order. So from the problems, I took them to the lean waste types. From there onwards, then I took them to the last planner system key features without mentioning the last planner system. So are you facing these types of things? So in case of this kind of things, what are the approaches you are taking? So if I'm going to implement this type of a thing, what are the things you might think coming as barriers, and what are the suggestions that you can give to overcome such situations? So that is the way that I have conducted the research, only to assess up to what certain extent these things practicing at the industry, a quantitative part was implemented. So similar results were obtained from there as well.
Okay, thank you for your answer. And because you have identified overprocessing as one of the main concern. So
Yeah.
I was just wondering regarding the construction industry, do you know any examples like, or any example activities related to overprocessing things? Because I couldn't really, because I'm not familiar with the construction industry itself.
Yes.
So yeah, the overprocessing related activities related in the construction industry, do you know any examples where the last planning systems would be able to solve such kind of issues?
Yeah, actually, I mean, overprocessing and the construction processes. So there we have, since construction is not a mass production or a manufacturing or a routine type construction, it's always a unique production.
Yeah.
So the it is different. It is really different with the manufacturing industry. So the overprocessing happens in certain processes, such as in procurement and coming for the logistics aspects for the procurement and the ordering material and the stocks at hand. So those things are similar
Okay.
to the manufacturing industry as well. So in these cases, people do not tend to identify whether it is overprocessing or not. So in that cases, from the last planner system, because they are the people who do the actual work. So from their aspect, if we get the involvement of them more broad way, rather than discouraging them, we are taking them to a planning, because only the managers do the planning. That is the results we obtain. So we need to get the bottom people and get their inputs as well. So it is not mentioned in the what we call the presentation, but the major problem adopting last planner system is the attitudinal problems, attitudes and the
Okay.
culture of the Sri Lanka. So
Okay.
I think I should mention that here.
Thank you,
Okay.
Lakshan.
Thank you. Thank
Thank
you.
you for your explanations, and thank you very much, Dr. Kaviratna, for your questions. So I'd like to invite the next presenter now. The title of this presentation is Generating Personalized Tour Plans with Maximum Satisfaction for Varied Tourist Needs. This paper has been co-authored by Ranga Dayavansha from University of Peradeniya and Subodha Dharmapriya, Romesh Samaratunga and Asela Karunatha from the Faculty of Engineering at the University of Peradeniya. Yes, you can start the presentation now.
Okay.
Ranga?
Our research is on providing optimized tour plan for customized tourist needs. So let's get to the presentation. Here is our research problem. So it's all about planning your next trip without browsing around the web. So let's clarify what is the need of a decision support system. So sometimes even if tourists made their own plans with the help of different kind of sources like websites or articles or magazines or social media or any kind of a way, it takes a huge time. It's more than you think. And also cost may be too higher than available budget, and also time plan may not fit with their needs, and also unable to find best scenic spots for the available budget and time period, and also it can be misleaded by the fraudulent persons, and also may not meet the facilities they have already expected. So it's kind of a big work with need of lot of time. So if we can provide the decision support system, it helps the tourist to narrow the universe of choices and also giving the results according to his or her preferences, and also it process much more information than tourists could possibly do in minutes. So our aim is to develop a decision support system for tour planning. So according to the studies that we have identified some common facts. With our literature review, we have identified many related research studies were focused on route planning and consider total budget and traveling time as their constraints. And also Dijkstra algorithm, shortest path algorithm, genetic algorithm are very common algorithms for route planning. And also most web applications, they have suggested to a package that they have already prepared. So it doesn't give much priority to the user preferences. So we try to address that part and provide more customizable tour plan to fulfill the customized customer satisfaction. In our system, we have identified demand and supply, and also what should we give as the output to the user. So here are the user inputs, favorite categories, favorite places, budget, and travel period, and also available resources of point of interest, and also the road network. And outputs will be locations to visit and route plan. So here is our mathematical model. The objective is to maximize the satisfaction of the preparing tour plan, and also constraints will be total budget to visit selected places does not exceed the available budget, and also the total time need to visit selected places does not exceed the available travel period, and also user preferred places if user selected, and also to a starting place and ending place as user preferred, and user selections within the provided options by the system. So here is the overview of our solver. When user inputs kind of data to our system and our decision support system, so we pre-process the data to identify what kind of input is that. So here we have identified 3 cases of inputs that user can give. So let me explain those cases briefly. So in case 1, user can input few of the categories and also few of the places. So categories can be beach sites or country, and also historical places or religious places or mountains or like that. So in places, he can specifically select Kandy or Arugambe or Hikkaduwa or any other place. In case 3, user will only select categories. We provide them to select few categories, so few categories and few places. So in case 1, he select both from categories and also from places. But in case 2, he only selects few categories. In case 3, user will only select few places. So let's see how the solver works in different kind of cases. So when user selects from categories and also from places, we have few categories like beach and historical places and like that. And also we have kind of places that user have specifically selected. They need to visit Kandy, Arugambe, and like that. So in this case, we consider the places that user have selected as preferred places are the places that user must need to visit, and we consider his satisfaction will be maximum when he visit the places that he have specifically selected, because he select those places specifically because they know about that place or they have much more interest in those places. In that case, we use route optimization first, then we use kind of heuristic approach and knapsack model, and also after that we use again heuristic approach after knapsack model to prepare the tour plan. In case 2, we use knapsack model together with heuristic approach, and also in case 3, we use only heuristic approach. let's consider about case one. They select some places from places and also they pick some categories. In that case, we give priority to the preferred places that user selects. So we take those places and prepare the tour plan and compare with the budget and travel period they have. And if it doesn't fit, we use heuristic approach to eliminate the places with lowest rating and find the best tour plan with the maximized rating within their budget and time period. If the prepared tour plan fits with the budget and time period, we calculate the extra time and budget they have. Then we use knapsack algorithm to pick some places from the categories that they have selected to fulfill the extra budget and extra time period. Then we use knapsack model and also we pick some places from the categories that they have picked, and we use route optimization and compare budget and time period with the extra time period, then extra travel budget they have. Then we use heuristic approach to eliminate the places with the lowest ratings to bring the satisfaction within the time period and travel budget they have. In case 3, we get all the places inside the categories together, and we use knapsack model to filter those places to bring closer to the constraints. And then we use heuristic approach to find most accurate result within their time period and budget and maximize the satisfaction. In this heuristic approach also, we eliminate kind of places with lowest rating. Here is the overview of the knapsack and heuristic approach works as I have explained earlier. So in case 3, we only have 3 or more places. So in that case, we only use heuristic approach. First, we prepare tour plan for the places that user have selected. Then we compare with the constraints, and if it doesn't fit, we go for heuristic approach and eliminate the places with lowest rating until user meets with the constraints, and we prepare and show the tour plan when we reach to a tour plan within the constraints while maximizing the satisfaction. This is the web application structure. There is a client side and server side. So this is the working flow of the application. When we get the input from the user, we send JSON request to the app logic. Then it deals with the solver and also the database, local database, and also Google Maps API. Finally, the app logic will generate the tour plan and send those data to the front end to process and show to the user. Here are the materials and equipments. We use Python language as main language, and then we use Django framework, and also we use knapsack library of CBX5 to use knapsack model, and also we use heuristic approach. Also we use a Google Maps API to get most accurate real world data. So here is our data set, as I have explained earlier, categories and preferred places, and these are the places within those categories, visiting cost of the places and visiting time, and also rating for the places. And here is the places that I have explained earlier. User can pick 1 or more places from this list. And also here are the case studies and tabulated results. So we have used 5 cases to go with the 3 cases that we have explained earlier. So we use different kind of inputs and different kind of input categories and different kind of input places and different kind of input categories. And here are the results that we have generated. So you can see the figures below, and these are the results that we have generated successfully. So you can see we have prepared a overall traveling map with the sequence of places they need to visit to reduce the cost and travel within the period of time that they have. And also here is the most important part. So we have generated results like this. So we have used more than 90% of the user available budget in 4 out of 5 cases. So, and also we have we were successfully achieved more than 90% of user satisfaction in 4 out of 5 cases. So it's a huge achievement. So I must mention this, that the satisfaction is considered as maximum rating when all places provided in the tour plan are picked by the user, because if the user pick some place, as example, if he pick he need to visit Kandy, that means that he thinks that he can get the maximum satisfaction when he visit Kandy, because he know about that place. So he have a kind of interest, personal interest in that place. So, and also when people use our system, we get continuously feedback from the users, and we update the ratings of the places according to the user feedback. So it will help the system to optimize the ratings of the places within the time. So when people getting used to this system, the system will automatically improve with the rating system. So that's all. Thank you.
Thank you very much, Ranga, for your presentation. Actually, we have very little time now, so I would like to limit the question and answering session to only 5 minutes. I would like to invite the audience and the co-chairs to ask the questions first.
Thank you very much, Ranga, for your presentation. It was quite informative. So I think you have tried different cases with different approaches, right? So in the third one, you have mentioned you're using a heuristic approach. So can you explain what's that heuristic approach? Is it something that you have designed or something you have taken from literature? So what is this heuristic approach that you are referring to?
Yeah, we have tried kind of few approaches, but finally, when we prepare a tour plan within the budget and time period, we can use kind of algorithms. But when we need to deal with the locations and route optimization, we can't combine knapsack or any other algorithm exactly with this problem. So that is why we use heuristic approach. Means that when we generate kind of tour plans and we use knapsack algorithm to bring the solution closer to the constraints, then we need to generate the most accurate tour plan within the travel period and budget while maximizing the satisfaction. In that case, we used heuristic approach to eliminate the places with the lowest rating while maintaining the highest rating for the generating tour plan. So what we actually do is we eliminate in the places with lowest rating while maintaining other constraints and maximizations.
Okay, Ranga, thank you for your answers. Have you implemented this currently?
Yeah.
What kind of observations you when it comes to the effectiveness of this system? What can you say about the effectiveness, current level of effectiveness?
Yeah, current level of effectiveness is not bad, but we are trying on optimizing the algorithm to get the maximum satisfaction. And also when practically people traveling, they need accommodations and like that. And also in practical world, there are traffics and everything gets together with traveling. So we are working on implementing accommodations to the system, and also we will be working on considering real-time road network traffics and all that kind of things to improve the system.
Yeah, actually, it's a very useful tool. I think there will be big demand if you can implement this for the general public. There will be a very big demand, and it's a very useful technique, a useful tool. Thank you very much for all the co-authors and for the presenter. I would like to invite the next presenter now.
Thank you.
Yes, this presentation is about blockchain technology applications in logistic and supply chain management. It's a systematic review of literature. The co-authors of the paper are Pavini Vasana Patirnage from the Department of Industrial Management at the University of Kelaniya, and Chatura Rajapaksha from the same department. Yes, you can start the presentation now.
When you see this picture, what comes to your mind? Do you know that counterfeit drugs pose a great threat to the public health? And according to the global reputation of medicine counterfeiting in the world, Sri Lanka has considered a country which has high level of counterfeit drugs. Can you see how supply chain is complex? And can you see that if we did not manage supply chain and logistic functions well, what will happen to the world? Hi everyone, I'm Pavani Vasana and my title is Blockchain Technology Applications in Logistics and Supply Chain Management, a systematic review of the literature and supervised by Dr. Chatura Rajapaksha. So this is the overview of my today's presentation. First, let's see the background of the research. When we come to the background of the research, practitioners and researchers have become increasingly interested in blockchain technology. Through smart contracts, blockchain can favorably influence monitoring, tracing, visibility, and confidence in the supply chain. At the same time, industry experts and supply chain managers have expressed an interest in using blockchain technology because tracking and authenticating data access to the whole supply chain is crucial. Now we'll move on to the research problem. Approximately 60% of the business leaders say lack of transparency between their finance and procurement functions and their suppliers represent a risk to their business. And according to the graph, if the transparency of the supply chain is low, companies become less successful. And do you know that many companies fail due to less transparency? So now we have a problem. How can we improve the transparency of the supply chain? Best way to increase the transparency of the business is to use blockchain. So here it shows the significance of the research. The market worldwide for the blockchain technology is rising according to the market reports. Blockchain technology in 22 in investments for the blockchain is $3 billion and it is expected to rise up to $40 billion in 2025. And here, as you can see in this chart, the highest amount of investments of blockchain is to supply chain. So my research comes here just to find out in which areas we have done the research and which areas we have to study. So here it shows the research questions. The first research question is what are the different ways that blockchain technology is being used in the supply chain and how are the core issues being addressed. And the research questions 2 is what are the most common research approaches used in the literature on blockchain-based supply chains and which blockchain-based supply chain management publications were the most influential papers on the development of literature so far? So when it comes to the methodology, a thorough literature review was undertaken on the issues in order to discover the answers to these research questions. So by examining current literature, the goal of this study is to provide a wide overview of the recent research and to identify the gap need to be addressed in the future. So last 4 years from 2018 to 2021 was considered to collect research papers. First step was the criteria for inclusion and exclusion article selection was done prior to the analysis by creating inclusion and exclusion in order to acquire highly relevant literature. 450 articles were obtained following this procedure, and in the meantime, exclusion criteria were established to eliminate unclear items that were not strongly related to key topics. And the second step was title and abstract examination. Based on the results of the keyword detection and screening approaches, the title and the abstract of each selected article were reviewed, and to ensure the quality and the standards, abstract with less focus on major subjects, a fewer contribution to the body of the knowledge were eliminated, and through this, 182 papers were eliminated. And in the third step, full text reading was used to perform the technique for better selection of candidate papers in order to better match the research questions with the context of selected papers. 136 papers were eliminated due to unrelated focusing area. So this figure shows the growth of the blockchain-based research over the last 4 years. And according to this, 34% of the research papers have published in this year. So, and you can see that in these publications have surged from 2018 to 2021. And also, this chart shows the most popular journals for the blockchain technology applications. So when we consider this IEEE Access, International Journal of Production Research, International Journal of Information Management, Electronics, and Sustainability, most of the publications of blockchain-based research have been published in these journals. And also, when we come to this chart, these are the publications which have mentioned more frequently, like they have, well, like I was divided like the topics into categories based on the maritime industry, pharmaceutical industry, agriculture industry, food industry, like that. And this chart shows the categorization of papers based on the type of industry. So many articles cover topics including traceability and transparency. And also when we consider the agriculture industry, most of the research papers in 2021 has been published in agriculture industry. And when we consider the food industry and pharmaceutical industry, many research papers have been published. But when we consider the industries like apparel industry, automotive industry, dairy industry, financial industry, healthcare industry, like that, very few amount of research papers have been published. So there's a huge gap. Like we need to study on this area also. So this also shows the results. So when we come to the analysis of the relevance of the topics over time, prior to 2018, the majority of blockchain debates were on the Bitcoin and digital currencies, and only a very few articles were published in the first year 2018, and supply chain traceability and transparency were the first subjects covered. And in the second stage of 2017, and blockchain integration with other developed technologies has gained the attention and emerged the general blockchain influence, security and privacy issues. And when it comes to the main research methods employed in the research, they were like most of the research have been published in architecture, building and system design. And other than that, case studies also have published a lot. But when we consider these like methods like SCM and systematic literature reviews, and other than that, like this other category, and also survey and interview, very few amount of researchers have been published. So quantitative methods are rarely appeared in previous studies because blockchain is still in its early stages of development. And when we come to the discussion of the research, because of the unique qualities of the blockchain, researchers and practitioners have become more interested in the previous decade. And the use of blockchain with the emerging technologies like Internet of Things improve the visibility and the performance and transparency. And also the immutability of the distributed ledger system reduces the frauds in existing traditional systems by preventing data manipulation. And as a result, an enhanced supply chain operating system with higher traceability and transparency with less intermediation and process automation is achievable when conducting blockchain transactions with counterparties. And when we come to the conclusions and future work, to date, we are aware of the research motivations for more open collaborative networks. The study's key contribution is a comprehensive evaluation of existing studies and citation analysis, provide a better understanding of the prevailing technology. And also, the aim of this study was to provide a comprehensive assessment and analysis of existing literature on supply chain management from the perspective of blockchain. And there's a need of studying the blockchain related technology concerns, including the security, scalability, and immutability to address the research gap, as there are very similar few similar initiatives. And also, quantitative researches in this area is still uncommon, as blockchain is at infancy, and more research is needed to be available on blockchain applications, their issues, and the social impact. And the other industries on blockchain should be addressed, as there are many research available on food industry and agro industry. So that's the end of my presentation. Thank you, everyone.
Thank you very much, Pavani, for your presentation. Yes, I have one question. on your research.
Yes,
You have summarized the literature published in this area related to blockchain technology within last few years' time.
yes,
And you
madam.
summarize the industries and the methodologies used in these articles and journals.
Yeah.
But actually, since you are publishing a paper on this literature review, I would like to know specific research gaps you have identified.
Yeah, madam, what I want to do was like when we consider the technology like blockchain, there are many advantages. Like for an example, if we take pharmaceutical supply chain, we can identify like due to less traceability and transparency, many issues are happening. Like most of the time, these counterfeit medicines are distributed because of this, like due to less traceability. So I wanted to identify in which industries these researchers have not been done, and which industry like we have to pay more attention. Like it's like to give an idea for the researchers, like in these industries we have to pay more attention, and in these industries we have paid attention up to now, like that, madam.
Yeah, what kind of things that previous researchers have said about this transparency and things like that? What are their findings?
Yes, madam. The
What is the gap?
findings, sorry, madam, I didn't get that question.
Yeah, what they have studied and what yet to study.
Yes,
But
madam.
they have not yet studied.
Yeah, they have not studied it like in most of the research papers. What I got was like they have proved like we can improve the traceability and transparency of the supply chain in most of the areas. But still there are some areas like if we take for an example this apparel industry and like dairy industry and an oil industry and construction industry, like that there is a more research gap. Like more research studies has to be done. Like in most of these research areas they have done, sometimes they have implemented applications, and but they have not like see whether are these applicable to these areas. So what I feel was like before implementing a technology like this, and like as this technology is it's in its early stages, so we have to like do some researches and see like if we like if we can adapt this technology to this area or like that.
Okay, thank you very much. So I would like to invite the audience and our co-chairs to ask questions if you have questions to ask from Pavani. Looks like no more questions. Thank you very much for all the
Thank you, madam.
presenters. Yes, thank you very much for all the presenters and the organizing committee of the ICLSE 2021 and Tilini for coordinating the session. I would like to hand over the session to Tilini to sum up the
Yes,
session.
yes. Thank you, Dr. Chaturani, for chairing the session. And all the panel members, Dr. Chaturani Silva, Dr. Chatumi Kaviratna, and Dr. Amila Tibotuao for your valuable comments and feedbacks. So before we wind up, I would like to thank all the presenters and the audience of this session for your time. Please join the second keynote of ICLSE 2021, which will be starting at 2 p.m. by Professor Hasis on seaport development aspects in connection with digital service innovations. So we look forward to see you and enjoying the rest of the events of the conference as well. Thank you so much for your participation.
Thank you.